Streams allow Scheme to process sequences while using an efficient amount of space, just like a Python iterator. But unlike iterators, which are mutable values, streams are immutable. They are just like scheme lists, except for that the cdr of the list is computed lazily whenever it is requested. So a stream is a list, but the rest of the list is computed only when the built-in procedure cdr_stream is called on the stream. Regular lists look like this. If I ask for the car of a list containing 1, which I build with cons 1 nil, then I get the 1 out. And if I ask for the cdr, then I get nil. Building a list of 1 and 2 can be done with cons 1, cons 2 nil. And streams just work the same way, except for that when I say cons, instead I say cons stream. It still takes 2 arguments. And the car of a stream containing 1 is just 1. The cdr stream of a stream containing 1 is nil. And to build a stream containing 1 and 2, I'd write constream 1, constream 2 nil. So far there are no differences, except for that cons has a stream and cdr has a stream. However, when constructing a stream using constream, the cdr expression is only evaluated when the cdr stream is requested, and errors only occur when expressions are evaluated. So if I were to write cons 1 divided by 0 nil, since this number cannot be computed, I would get an error immediately. I can't build a list containing 1 and whatever this might be. But building a stream is possible. Constream 1 divided by 0 nil builds a stream where the first element is 1, and since nothing has requested the cdr of this stream yet, the expression that would create that cdr has not yet been evaluated. It says promise not forced. A promise is Scheme's way of representing a value that could be computed if that were required, but for now hasn't been computed yet. A good way to think about a promise is it's this expression, which could be evaluated later, as well as the environment in which it will be evaluated. In fact, if you ask for the car of this stream that starts with 1, you'll get 1. But if you ask for the cdr of this stream that starts with 1, that means computing a stream that would start with whatever this evaluates to, but this can't be evaluated without an error, so you reach an error. So let's go through this demonstration again using the scheme interpreter. If I define S to be a stream starting with 1, and then 2, and then nil, I can get the car of S, I can get the car of the cdr of S, and I could get the cdr of the cdr of S. And it behaves just like a regular scheme list. If I define T as a stream that starts with 1, and then it follows with a value that doesn't exist, let's see what happens. S and T currently look identical. They're both streams that start with 1, and we'll see what comes next whenever we compute the cdr stream. The cdr stream of S is a stream that starts with 2. The cdr stream of T doesn't exist because we tried to evaluate it, and evaluation of this expression caused an error. Now you could build a stream by consing and then consing again, or by writing a procedure that does that for you. So instead of a range, I could build a range stream, which gives me a stream of values from A to B. All this code is the same. If A is greater than or equal to B, then it's an empty list, which is the same as an empty stream. Otherwise, I'm going to constream A to range stream A plus 1b, and let's see what the difference is. A range from 1 to 10 is a list, and a range from 1 to 100 is a longer list. A range from 1 to 1,000 I can't compute because this isn't a tail recursive procedure. But if I could compute it, it would have 1,000 elements all in a row and would fill my screen. What about a range stream? Range stream 1 to 10 has computed the 1, but it hasn't actually recursively called range stream again yet, because that's the second expression in the constream special form, which only gets evaluated if somebody calls cdrstream on it. So let's be that somebody, call cdrstream, and we'll see the number 2. And there's the number 3, etc. So I can get all these values just like I could with the range, but they haven't been computed until cdrstream is explicitly called in order to compute them. One interesting consequence of this implicit representation of a range is that although you have access to as many elements as you want, using code that's almost identical to what we wrote for building a range, we can build a huge range stream without anything crashing, because it's only actually computed the number 1, and has an expression which could compute the rest if it's time to do so. The car of this is 1, the car of the cdr is 2, the car of the cdr is 3, and we can compute as many values as we want, all the way up to this very big number, but all the work required to do that won't happen unless enough calls to cdrstream are used to request it.